Alright, in this video I'm going to introduce you to how we add and subtract rational expressions. So we'll start by adding and subtracting rational expressions, also known as fractions, with like denominators, and we'll be heading into basically preparing for how to add fractions with unlike denominators. That'll be the second video. So let's go ahead and get started. So first of all, if I were to say add, and I gave you 3/4 plus 5/4, you would add the numerators and you'd get 3 plus 8, or 5 is 8, and you would get 4 as a denominator, and this is equal to 2. If I asked you to subtract, and I gave you 9/14 minus 5/14, you subtract the 9 and the 5, you get 4 over 14, which reduces to 2/7. And so it's pretty simple to add fractions that have a common denominator. So first of all, we add or subtract the numerators. And then we keep the denominators. Now, just to kind of illustrate this, let's look at candy bars or chocolate bars. Does it make sense that we don't change our denominator? Well, let's see. If we have a candy bar in fifths, so this would be 1/2, and we add that to a candy bar again in fifths. I didn't draw it to look the exact same, but it should. So let's just put 1/5 here. 2/5 plus 1/5 gives us 3/5. So basically the denominator doesn't change because it tells us the size of the pieces. Each piece is 1/5 of a candy bar. And so this is 2/5 of a candy bar, and this is 1/5. If you add the numerators, 2 and 1, that tells you how many pieces you have, and again, each piece is 1/5, and so we get 3/5. So anytime we add or subtract fractions that have a common denominator, we don't change the denominator. Not until we get to a point like here where we're just simplifying the fraction. But here you'll notice the 14 didn't change, the 4 here didn't change. All right, let's continue on. So now we're going to do some more algebraic types of problems. So we have a common denominator here, so we can add our numerators. We get 2x plus x minus 6. Now I could put parentheses around these, but I would just drop the parentheses anyway. And that's going to be over x plus 2. So all I did was add my numerators. Now I can add the 2x with 1x, and I get 3x minus 6 over x plus 2. Now this numerator does factor. We could factor out a 3. Remember, when we get our answers, excuse me, we talked about this when we were simplifying rational expressions. When we get answers to a problem like this, we'll always give a simplified answer. So we could write the numerator as 3 times x minus 2, but notice that doesn't help us to simplify this. If these were both x plus 2's, we could cancel them, but they're not, so we'll just rewrite. We'll just write it like this. We tend to prefer the factored form just because it's clear that there's nothing else that you can simplify. So let's go ahead and do the next one. Now this time we're subtracting a binomial, and so I'm going to want to use parentheses here. So it's the numerator of the first fraction minus the numerator of the second fraction. And again, our denominator doesn't change. Now here we're going to drop the parentheses. This is basically a 1, and 1 times anything is itself, so we'll have 3x plus 1. But here we have to distribute a negative, so each of these terms are going to change signs. We'll get a minus x, or minus 1x, and a minus 17. Again, that's over x minus 8. So we can combine some like terms. 3x minus 1x is 2x, and 1 and negative 17 is a minus 16. In the denominator, we have x minus 8. Now, if you stopped here, you would actually miss something because this is not simplified. Notice there's a GCF in the numerator. You can write this as 2 times x minus 8 over x minus 8. So notice these x minus 8's cancel, and you're left with 2. All right, the last one here, there's something we need to deal with here. So notice our denominators aren't the same, but they look very similar. So this is the one that looks wrong. It should be a minus 4, so it's kind of backwards. So I want you to notice something. If I have 4 minus a, I could write that as minus a plus 4. And now I could actually factor out a negative 1 so that I get an a minus 4. I can write this as negative 1 times a, right? That would be the minus a, basically factoring out a negative 1. And negative 1 times negative 4 would give me this 4 here. So I could write this as 3a over a minus 4 plus 2 over negative 1 times a minus 4. Now here's where we have something else we need to remember. If I have a fraction, which is what I have here, like for example, negative 3/4, I can put the numerator, or I'm sorry, the negative with the numerator, or I could put it with the denominator. So all of these are equal. They actually all equal negative 0.75 if you were to divide the 3 by 4. So these are all equal. So I could actually rewrite this as 3a over a minus 4 plus, I'm going to put the negative in the numerator here, and so it won't be in the denominator anymore, and 1 times a minus 4 is just a minus 4. So this fraction is the same as this one here. In fact, I could have written this as minus and just put the 2 here. Either way would work. So we have 3a plus negative 2, which is 3a minus 2, over a minus 4, and that's going to be our answer. Now I want to remind you that you might be tempted to cancel a 2 here, divide each of these by 2, but you can't do that because this is a term and this is a term, and we learned that you cannot cancel a term or part of a term. Same thing here, I couldn't cancel the a's here because this is a term and so is this. There's 2 terms here and 2 terms here, so we can't do anything further. We'll stop right there. Now before we get into adding fractions with unlike denominators, we need to talk about 2 things. The first is equivalent fractions. So equivalent fractions are fractions that look different, but they're equal in value. By the way, I apologize for my voice. I'm losing it tonight. So anyway, you have 1/2 and 2/4, for example, that are equivalent fractions. Same thing with 5 over x and 50x over 10x squared. Notice if you divide by 10, you would get 5 here. Divide by 10, and you'd get 1 here. And one of these x's would cancel this x out, and you'd be left with 1. And so this would be 5 over x, which is the same. So these are also considered equivalent fractions. So it says, rewrite each of the following fractions as an equivalent fraction. So there's a little trick that we use. And what we're going to do is we look at the 3 here, and I want to change that denominator to 45. And so notice 3 times 15 would be 45. Now to make it legal, got to do the same thing to the numerator. And so what I'm really multiplying by is equal to 1, and that's what makes it work. 2 times 15 is 30. This is what we call building fractions, and we do it by multiplying a fraction by some number over itself. And why do we do this? So we can change our denominator. Again, this is called building fractions. So 3 times 15 is 45, and 2 times 15 is 30. If you reduce this fraction, you'd be back to the 2/3. So notice here, to change 2x to 6x squared, I have to multiply by 3x. Well, whatever I did to the denominator, I'll have to do to the numerator. So here we'll get 15x. And so this fraction is equivalent to the original one. Now look at number 3. Notice this is a difference of squares. This can be factored as x minus 3 times x plus 3. So I'm just going to put a mark through here and replace it with that. So notice, to get this denominator that I want, I have to multiply this x plus 3 times an x minus 3. So we'll do the same thing in the numerator. And so we get negative 3 times x minus 3. Now you could multiply these out, but I'm just going to leave it just like it is. Again, notice if you canceled the x minus 3's, you'd be back to where you started. And you could write this as negative 3x plus 9. All right, so I would encourage you to try number 4. It's very similar to the one we just did. All right, let's see how you did. So here, when you factor this denominator, you're going to need 2 numbers that multiply to negative 28 that add up to 3. Well, it looks like 4 and 7 are going to work. And these should have opposite signs. Since they multiply to a negative, and since they add to positive 3, we want to make the smaller number negative. So notice negative 4 times 7 is negative 28. And negative 4 plus 7 does give you 3, so we can go ahead and plug those in here. So it'd be m minus 4 over m plus 7. Remember, when we're using the AC method and we get our numbers, if this is a 1m squared, we can just plug our numbers right in like I just did here. And so now you can see I need to multiply by an m minus 4. So I'll have to do the same thing to the numerator. And we get m squared minus 4m. Or I could have written it as m parentheses m minus 4. All right, so let's move on to the next page. And let's talk about least common multiples. It says to find the least common multiple for 2 algebraic expressions, we'll do the following. So find the LCM of the numbers and identify any algebraic factors. So we'll talk about what I mean by that. And then we'll find the LCM. It's going to be the LCM of the numbers times each algebraic factor found to the highest power found. So let's see how this works. So here, these are just numbers. So we want to find the LCM, or the least common multiple, for 4 and 6. Whoops, let me fix this. All right, so The multiples of 4 are 4, 8, 12, 16, and so on. We just keep adding 4, or you could think of it as 4 times 1, 4 times 2, 4 times 3, and so on. The multiples of 6 are 6, 12, 18, 24, and so on. Notice 12 is the first one in the list, the smallest multiple that these two numbers have in common. That's what we mean by the least common multiple. So our LCM is 12. Now there's another way to do this. Just look at the larger number, which is 6 here, and until you find a multiple that's divisible by the lower number. Well, 6 is not divisible by 4, but the next multiple of 6 is. 12 is divisible by 4, and so that'll be your LCM. 12 is actually a multiple of 4. So again, you can go with the bigger numbers, or the multiples of the bigger number, until you find one that's divisible by the other number. So why don't you try that and see if you can find the LCM on number 2. All right, so I'm assuming you stopped the video. If you did that, the bigger number is 15. 15 is not divisible by 12. The next multiple of 15 is 30, which is also not divisible by 12. We'll add another 15, we get 45. That's not divisible by 12, but 60 will be. 60 divided 12 is 5. And so our LCM here is 60. Now on number 3, we don't have any numbers. We do have some algebraic factors. In fact, the only thing we have is an algebraic factor of x. This has 1 factor of x, this has 2. So remember what it said, it's each algebraic factor found to the highest power found. Well, the only power of x we found, I should say the only algebraic factor we found was x in these two, and the highest power found is x squared. And so that's going to be our LCM. All right, so for number 4, notice we're going to have to find the LCM of the numbers, and then we do have an x algebraic factor we need to include. So the LCM for 6 and 8, let's look at the bigger number and its multiples. 8's not divisible by 6, and neither is 16. But notice 24 works. And so our LCM will include the 24, the LCM of 6 and 8. And we need to include any algebraic factors that we found. And that is only x to the highest power found. Well, they're both to the first power. So this is our LCM. Now on number 5, we got to be careful here. We know that x is an algebraic factor, but we actually have to treat x plus 5 as an algebraic factor because there's no product here. It's x plus 5. So we don't know what x is, but we know that x plus 5 would be 5 more than x. It's some number, we don't know what it is. Same thing with x minus 3. The only thing we can do in a situation like this is multiply x plus 5 times x minus 3. So we took each algebraic factor found, and they were each to the first power. I mean, we could do this. And so they're each going to be to the first power here. Now, I do want to point out, for example, here, we could have multiplied 12 times 15, and we could have gotten a multiple of 12 and 15, but it wouldn't be the smallest or the least common multiple. But if we don't know what the factors are, we don't have any choice but to multiply them. So anytime you multiply the two numbers, you're going to get a common multiple. It's just not necessarily the least common multiple, but with algebraic factors, all we can do is multiply. All right, so let's look at number 6. The first thing we're going to need to do with these two expressions is factor out the GCF. This is 4 times y plus 2, and 5y plus 10 can be written as 5 times y plus 2. So you'll notice, first of all, we have a common factor of y plus 2. Or I should say, each of these has a factor of y plus 2. That's going to be our algebraic factor. But we also need to find the LCD of 4 and 5. Well, if you look at the multiples of 5, 5 is not divisible by 4. Either is 10 or 15, but 20 works. And so your LCD is going to be the LCD of the numbers times any algebraic factor found, and all we found was y plus 2. All right, 2 more problems to go here. So you might try these and see if you can figure out what the LCD is. They're a little bit different. So first of all, you would want to factor this, and I'm going to assume that you know how to factor. This would be x minus 5 times x plus 4, and I'm going to just cross this out. I just replaced it with its factored form. So notice all the algebraic factors we found, just x minus 5 and x plus 4, and all we can do is multiply them together. Now you might be tempted to write x minus 5 squared, but that's not how it works. Here we have a factor of x minus 5 to the first power. Here we have an x minus 5 to the first power. And so the highest power found for x minus 5 is to the first power. And so this is our final answer. That is our LCM. Now hopefully you noticed here this is a difference of squares. This factors as y minus 2 over y plus 2. And so you can see we had a y minus 2 factor here, a y plus 2 factor here, and these are just repeated. All of these are to the first power. I mean, we could do this, but our final LCD is y minus 2 times y plus 2, because those are the only factors found, and they were the highest power found was to the first power. All right, so that's the first video, and again, the next video we'll talk about how to add or subtract rational expressions or fractions that do not have a common denominator. All right, that's it for this video.